Hi, welcome once again to Domoji Math and Science. In today's lesson, we'll be seeing how to solve with special angles. In our last lesson, remember we dealt with the right angle triangle. We saw how to use SOHCAHTOA and also how to use Pythagoras theorem. Today, I'll briefly be explaining to you how to derive these special angles and their various degrees. Now, we will use an equilateral triangle. For an equilateral triangle, remember that an equilateral triangle is a triangle that has all its angles being the same and also all the sides are the same. If I have my equilateral triangle this way, that means these angles are all 60 degrees because the angles are what? The same. The sum of angles in a triangle is equals to (180°). That's sum of angles in a triangle. 180°. Now all my angles here are the same. If this side is 2, that means for an equilateral triangle, all the sides too are the same. If this side is 2, this side will be 2, this other side also will be what? 2. Let's take this down. Or equilateral triangle. Let's name it A, B, and C. Because it's equilateral, all the angles here are all 60 degrees. Let's take this place to be 2. Then each of the sides are what? 2. I'm going to divide this triangle into 2 symmetrically, such that if I'm dividing this into 2, this side will become 90 degrees, and this line here will be divided into 2. I'll have 1 here, then I'll have 1 here. Let's call this part D. If I divide this into 2, then this side is already divided into 2. What I should have here should be what? 30 degrees. What I have here should be what? 30 degrees. That is, my triangle should begin to look like something like this. This is 1. This is A, B, and here is D. Here will be 30. Here will be 60 degrees. Here is 2. One question you should begin to ask is, what is this side? Remember from our Pythagoras theorem. Now I'm labeling this side. If this is my big A, I can label this side my small a. This is my big B, I can label the opposite side my small b. This is my small big D, I can label this side my small d. Now for triangle ADB, I can confidently say that from Pythagoras theorem, my D squared will be equals to A squared plus B squared. Remember that's what? Pythagoras theorem. So that my 2 squared is equals to 1 squared plus B squared. 2 times 2, that's 4. Here is 1 plus B squared. So that 4 minus 1 is equals to B squared, and B will be equals to 3 root of 3. So this side confidently is root what? 3. So I can substitute root 3 for what I have here. Now, if you look at this, from here I can conclude that I can now take, let me wipe this with triangle A, D, and B. Here is 60 degrees, here is 30 degrees, here is 2 and 1, and here is what? Root 3. Now, simple. From here we can conclude that sine of 60, which is equal to opposite over hypotenuse, will be equals to opposite, that's root 3, over 2. At the same time, the cos of 60, which is equal to adjacent over hypotenuse, will be equal to the adjacent of 60, that is 1 over 2. Now let's work with 30. For 30, the sine of 30, which is same thing as opposite over still hypotenuse, is the same thing as 1 over what? 2. And the cos of 30, which is adjacent over hypotenuse, is equal to root 3 over 2. Now, with this, if you can work with your sine 60 as root 3 over 2, cos 60 as 1 over 2, sine 30 as 1 over 2, cos 30 as root 3 over 2. For those writing JAMB and other related exams that you will not be using calculators, you will find this very for 45 degrees. We'll be using an isosceles triangle. The unique characteristics of an isosceles triangle is a triangle that has 2 of its sides equal and 1 different. If this is a right angle triangle and it's an isosceles triangle, this is 1 and this is 1. Obviously, this side will be 45 degrees and this side will be what? 45 degrees. For my Pythagoras, let's call it triangle A, B, and C. From Pythagoras theorem, this side is a small c, side C is equal to 1 squared plus 1 squared. That's our Pythagoras theorem. So that that's c squared. C squared now equals to 1 plus 1, which is equal to what? 2. C is equal to the root of 2. So that C here is root 2. So whichever of the 45 you decide to pick, if you are using 45 at this side, we'll be saying that cos 45 degrees is equal to 1 over root 2. And sine 45 degrees will be equal to 1 over root 2. We left something out. We left tan 30 and tan 60 out while we were solving for sine 60 and cos 60. But for tan 45 degrees, we'll be talking of opposite over adjacent, which is equal to 1 over 1, that's 1. Now, one unique thing with 45 degrees, if cos 45 is equal to 1 over root 2, sine 45 is equal to 1 over root 2, that implies that sine 45 degrees is equal to cos 45 degrees. Now, for tan, let's go back to our triangle. Remember, we had 60 and 30 degrees, root 3, 1 and 2. Tan 30 will obviously be opposite over adjacent, which is equal to opposite is 1 over root 3. And cos and tan 60 and tan 60, let me just put that here, will be equal to adjacent over tan 60 is equal to opposite over adjacent. That's tan 60 will be root 3 over 1, which is equal to root 3. Now, with this, we've been able to take care of special triangles. But I'd like to put our results out in a more conspicuous manner. We can now see that we have shown that our tan 30 is 1 over root 3, sine 30 is 1 over 2, cos 30 root 3 over 2, tan 60 is root 3, sine 60 is root 3 over 2, cos 60 is 1 over 2. tan 45 is 1, sin 45 is 1 over root 2, and cos 45 is 1 over root 2. If you find this very relevant, like I said, if you are preparing for JAMB, GMAT, and other related exams where calculators are not needed, you will find this sort of angles. The beautiful thing about it is, if you understand how to use the triangle, you can easily draw the triangle and get your results. See you in our next class, where we'll expand more on trigonometries.